This video covers section 11.4, properties of logarithms. Objective 2, write a logarithmic expression as a sum or difference of logs. Remember that when we multiply like bases, we add those exponents. And now, since logarithms are exponents, when we multiply like bases, we add their exponents. So this tells us that when we have a logarithm of a product, we're going to go ahead and add those two logarithms, which are exponents. So because we multiply with like bases, adding exponents, we're going to go ahead and add the logarithms when we multiply. So it says the log of a product, where a product inside of a log becomes the sum of the two logs. Log of a product of two things says we split it up as a sum of the logs of each piece. Log base 8 of 7 plus log base 8 of x. Natural log is a logarithm, and so the natural log of a product, natural log of 8p, is the sum of the natural log of 8 and the natural log of p. Practice 3 is for you to try. I encourage you to press pause on your video and work this out, and come back when you're ready to see the solution. Now that you've had a chance to work this out, I'll work this out with you. The log of a product, we split it up as the log or sum of the two logs. Log base 4 of 6 plus the log base 4 of z. Natural log of 3 times r. 3 times r tells us to separate the natural log of 3 and the natural log of r. Again, the log of a product is the sum of the two logs. The next property comes from the fact that if we divide like bases, then we subtract the exponents, so that if we divide inside the log, then we're going to go ahead and subtract those two exponents, since a logarithm is an exponent. So in words, it says the quotient rule states that the log of a quotient equals the difference of the two logs. When you have a quotient, you separate the two logs by a difference. Log base 2 of x minus log base 2 of 9. Natural log of a quotient, natural log of 7 minus the natural log of 2. Log of a quotient is the difference of the logs. Here are two practice problems for you to try. I encourage you to press pause on your video and work these out, and come back when you're ready to see a solution. Now that you've had a chance to work these out, I'll work these out with you. When we have a log of a quotient, or there's division inside the logarithm, we split this up as the difference of the two logs. The log of a quotient, the natural log of r over 3, we separate that as the difference of the natural log of r and the natural log of 3. Now, example 3, we have the log of 4x over y, or 4 times x over y. So we'll have to sequentially apply these rules. So the first one I'm going to look at is the quotient. By the quotient rule, we have the log base 4 of 4x minus the log base 4 of y. The numerator is 4x, denominator is y. Now we have the product rule because of the 4 times x. So we split that up as log base 4 of 4 plus log base 4 of x. And we still have the minus log base 4 of y. So one of the takeaways from this is you've got the 3 pieces at the bottom. And the pieces that have positives in front of them, the first one and the second one, they came from the top as 4x. And the minus was in the bottom because of the negative exponent. So here are 2 practice problems for you to try. I encourage you to press pause on your video and work these out. Then come back when you're ready to see a solution. Now that you've had a chance to work these out, I'll work these out with you. We've got the log of a quotient, so that splits up as the difference of the 2 logs, placing the numerator in the first one and the denominator in the second one. Now the log of the product, log base 2 of 3m, becomes log base 2 of 3 plus the log base 2 of m. That's the log of a product, which gives us the sum of the 2 logs, minus log base 2 of n. Now letter B, we've got the 3 p's in the denominator, the 3p in the denominator and the q in the numerator. And remember from the practice, from example 3, anything that was on the bottom turned out to be a negative exponent, and anything on the top turned out to be a positive in front of the log, or exponent. So we apply the quotient rule first, the natural log of q minus the natural log of 3 times p. Natural log of q is done, but this is the natural log of 3 plus the natural log of p. But the minus sign is on the sum, and we have to distribute it. So it becomes a minus natural log of p. And it's for that reason that it's helpful to remember that anything on the bottom is going to turn into negatives when you separate them down into their logs. Natural log of q minus natural log of 3 minus natural log of p. Another useful property of logarithms allows us to express powers on the argument of the logarithm, that's the m, there's a power on m, as factors, and so it brings that r down in front. We saw something similar to it with inverse properties, where the r would come down in front of the log base a of a, but that property says that that's 1. So this property refers to if we don't have the base and the argument match. And so all it says is that the power is going to come down in front, r times the log base a of m. So since this is a practice problem, I'd like you to try this. Press pause on your video and get an answer and come back when you're ready to see the solution. Now that you've had a chance to work this out, I'll work this out with you. So if the quantity we're taking the log of contains an exponent, it can be brought down in front. So we say bring this exponent down in front and have it 1.6 times log base 2 of 5 rather than log base 2 of 5 to 1.6. You can see how this would be beneficial That's because 5 to the 1.6 could be a humongous number. Well, what we're literally looking at is 1.6 times the log base 2 of 5. Whereas the log of b to the 5th, remember this is the log base 10 of b to the 5th, and the 5 comes down in front, which gives us log base 10 of b. We like to omit the base of 10 when we can, so we just write 5 log b. Now we can put all of the properties together. And the phrase we like to use is expand the logarithm. So we'll just make it bigger, sums and differences of multiples of logs. So I see the log of a product there, x squared times y cubed. That gives us log base 2 of x squared plus log base 2 of y cubed. Log of a product is the sum of the logs. Now we apply the last property we just learned, which is if there's an exponent, bring it down in front. There's your sums and differences, sums or differences of multiples of logarithms. Letter B, this time I see a quotient first. So I take the log of 100x squared minus the log of square root of y. That's the log of a product, so we have log of 100 plus log of x squared. Now we need to remember that this square root of y is really an exponent of 1/2. And we need to remember this is base 10. So log base 10 of 100 is 2 because 10 squared is 100. This 2 on the x squared is going to come down in front. And this 1/2 is going to come down in front as well. If you like, you can put those 10s on there. It's just not necessary. 2 plus log of x minus 1/2 log of y. Here are 2 practice problems for you to try. I encourage you to press pause in your video and work these out, and come back when you're ready to see a solution. Now that you've had a chance to work these out, I'll work these out with you. Log of a product. We split this up as the sum of the 2 logs. Log base 4 of a squared plus the log base 4 of b to the 5th. Now we take the exponents down in front. 2 log base 4 of a plus 5 log base 4 of b. Letter B, we have a log of a quotient. Log base 3 of the numerator, 9m to the 4th, minus, log of quotients are minuses of the logs. Log base 3 of cubed root of n. The log base 3 of 9 times m to the 4th is the log base 3 of 9 plus the log base 3 of m to the 4th. Minus log base 3, and we're going to write that as n to the 1/3 for its exponent. Now, log base 3 of 9 is 2 because 3 squared is 9. The 4 comes down in front, and the 1/3 comes down in front. This concludes the video for section 11.4, Properties of Logarithms. Objective 2, write a logarithmic expression as a sum or difference of logarithms.